In this video, we're going to be looking at light. To humans, light is the most common form of electromagnetic radiation, as it allows us to see the world around us. Light comes in many colours, as seen in a rainbow. Light can be reflected and refracted, each having its various purposes to us in society. It is important to know the different types of reflection that can occur on different types of mirrors. A flat surface is perhaps one of the most important things you need to know about reflection. On a flat surface, the angle of incidence is always equal to the angle of reflection. This is known as the law of reflection. Basically what this means is, whatever angle that the incident beam comes down in will be the same angle that it reflects off at. In a concave mirror, the light can come in and then is reflected away at different angles. And the middle one can pretty much just go straight back. This is used in mirrors such as you see in parking lots and whatnot, where it's slightly rounded, allowing you to see a wide field of view, as the light is not only just reflected back at you, but also all around it is reflected. Another important surface is a concave surface. In a concave surface, the light beams come in, are reflected down at an angle, and meet at the focus point, and then continue off. This concept is very significant and is used in parabolic mirrors, as the weak signals are able to all focus on one signal point, making the signal being received much more intense and easier to detect. Another important element of light is refraction. Basically what this means is that as light goes from a less optically dense medium to a more optically dense medium, it slows down and bends towards the normal. Once it leaves, it speeds back up and bends away from the normal. An important formula you need to know is Snell's law. Snell's law states that V1 over V2 equals sin I over sin R equals lambda 1 over lambda 2, which equals N2 over N1. Basically, this formula shows the relationship between all these different elements, them being the velocity, the initial velocity, and the velocity once it's refracted, the sign of the incident beam as well as the sign of the refracted beam, the wavelength in the first medium, and the wavelength in the refraction medium, and the refractive index of the second medium over the refractive index of the first medium. Basically, all these aspects will give you the refractive index of a medium. This shows how much light will be refracted when entering this medium. For a measuring stick, the refractive index of air is considered to be 1.0. Here's a diagram that represents refraction. Basically what the diagram shows is that a light beam entering a more dense medium, bending towards the normal, and then leaving the medium again, bending back to the original angle and continuing parallel to what the original light beam would have been. You can see that the incident ray is here, and the refracted ray is here, measured against the normal, which is a line that is perpendicular to the point of entry of the light. As always, there's some more study material below this video,